Yeah, this is my 3D printer I was working on. This is like the second video of this. I'm not really into the videos on the 3D printing, but I'm making that rotational 2-axis positioner for 5-axis machining, and I needed to get my 3D printer a little more reliable because a lot of these prints they're 10 hours, 15 hours for the big parts, and the small parts they're a couple hours, whatever. But anyway, I was working on my printer, and I was just making some changes to it. And the first video I talked about setting the bar level with the table, and that didn't I mean, it seemed like a great idea, but in reality it just didn't work, because as soon as the motors disengaged, it dropped. The bar dropped. Let me show you. Yeah, you got the bar, and you got the one lead screw here, the other one here, and then you got all this motor stuff on this one side. And as soon as the power gets disconnected, or you stop the print or something, this one side sinks because of all the weight here, and this side stays up. And if your bed is level with this bar when you first start, like what I was trying to do, and then you stop the printer, this side sinks, so now you're tipped. So now when you re-engage it, this bar is on an angle, and the table's still flat, so when the printer gets over here, it's up further than it is from over here. So the concept was good, but in reality it just didn't work. So I had to do something different. And so what I ended up doing was just leaving this bar alone and setting the table to the bar. So when the bar is on an angle, the table is basically on an angle too. And that's the way that ended up. But the other issue that I was having, and I guess most people have it, is with these little clips that hold the boron tube on. So this tube that feeds the PLA into the unit goes into these clips, and these push down, and there's little fingers that grab this plastic and hold it in place. But what happens is that the fingers are so small that after a while they tend to bite into this plastic, and they tend to squish it, because this little piece right here that sits on top of the heater unit, it gets warm. So this one here is the Capricorn, and the clear one is the standard one. Yeah, here's my 3D printer. I have it on the side. This is the bottom. This is the bottom. This is the top. Making a little modification to it. And I had to tip it over because I took the hot unit off. And there's wires from the hot unit that go into this plug, and I had to tip it on its side so I could get those connections off. I was trying to get them when it was upside down, but it was just too hard. So anyway, what I'm doing here is I'm taking this 1/8 NPT tap and I'm making this a little bit bigger. The one that comes with the machine and the ones you buy, I guess, are metric, and they're smaller than the American NPT, and I'll show you why. Let me pause this while I get the other part. This is the this is a 1/8 NPT I got from the hardware store. And what happens is it only goes in like 2 turns on the metric. So what I have to do is I have to take this 1/8 NPT, and it's got the end of it cut off. I borrowed this from work, and I have to sink that in a little bit deeper. I have to sink it in another 5 threads. So I brought home a wrench, and I'm going to go ahead and do that. But I thought about taking this cap off, but I thought, well, you know, it's you know, you got to take this off, take that off. Maybe I can just do it right here. No point in taking any of this apart. I mean, if it starts to move or something, I'm not going to be that rough with it. It's just basically pot metal. It's going in there really easy. But that's just one of the changes I'm making to it. I'll show you the rest of them in a few minutes. But this camera on this phone doesn't like the focus very well. Yeah, that went in about 3 or 4 threads already. All right. So this is the Capricorn tubing, and it's a little thicker, but I had the same issue as the standard tubing, that it would tend to dig in and collapse. And it's basically these fittings that I was having problems with. Now, when I ordered this Capricorn tubing, they sent me all these new fittings, and they sent a couple of boots to go on the bottom. I bought the whole kit. They send you a whole bunch of different fittings, a couple of boots to go on the bottom of the unit. But I was still having the same problem. And what I did before was I raised the fitting off of the top of the unit higher, and I was thinking that might get away from the heat source and keep that from collapsing that tube. And I really wasn't happy with that. I mean, that was like a band-aid. It really didn't fix the problem. And what I ended up doing was I made these blocks. These are little clamp blocks. And I ended up going back to the regular tubing, because this Capricorn, I mean, it's great, but it's more restrictive. It's tighter on the ID for the PLA to go through. And I guess it's because when it retracts, it has to back up and move down, and the unit doesn't move up and down like a CNC machine. It backs up the PLA and then pushes it forward, and that's how it retracts. But this tubing is tighter, and it was, when I put it through there, it's just too restrictive for what I'm using it for. I'm using it for big items, bulky items, and I'm not looking for detail. I'm looking for just to get the item done and make it work. And I don't need really fine detail. But to solve this problem for once and for all, I made these little clamp blocks. Now what they look like, I just took a piece of aluminum, sliced it in half here, milled it. Then I made a piece to fit on there, and I clamped it, and then I put the hole in there for this tubing to go through. Now this tubing, the outside of this tubing is the same size as the standard tubing. The standard tubing is the one I'm using now. I mean, I tried this Capricorn, but it's the inside is too restrictive for what I'm trying to do with it, but the outside is the same. So what happens is it just goes in there, and then you just clamp it. So what's happening here is that you're getting, however long you make this piece. I mean, I made this one, I don't know, it's about a ½ inch. So you're getting a ½ inch of clamping surface here instead of these little fingers. And now these fingers are, I don't know, maybe 10 thousandths thick, and there's like a little ring. So you're getting a lot more clamping surface, and you're clamping on the OD of the part, the OD of the tubing, instead of one little area, and it working out really good. I mean, I had no issues at all with this. It doesn't collapse this. It doesn't collapse the tubing. It lets it feed in there nice. It retracts nice, and it doesn't squish it. So I drilled that hole the same size as this tubing, And then I came back and I took a couple of thousandths off this block so it gives a little squish factor. Now you can take as much off as you want. I mean, in reality, you could have most of the hole over here and a little cap over here. Well, let me. You could, if this was your block, you had it cut like that. I mean, it doesn't matter if you had most of the hole over here and a little piece over here, so long as it clamps. I tried to center it as much as I can, but it wasn't that critical, is what I'm trying to say. So long as this piece clamps onto this piece, and even if you had a nice little gap in there, as soon as you tighten those screws, you can feel it tighten down, and you don't want to go too far. You just want to tighten this tubing in that block. And like I said, that worked out real good. I'm really happy with that. And it wasn't that hard to make. It's just a hole in there. Tubing fits through there. And the issue I had was with this, I got this 1/8 NPT from Ace Hardware. Well, I got two of them. I got one for the part that feeds the PLA out of the motor, the thing with the little gear on it, and then I got one for the hot unit. And the issue that I had, I mean, I tried this. The standard NPT metric thread is really small. The American NPT seems to be bigger. I don't know why, but it is. So when I first did this, I used the standard NPT tap, and I had it going in about 2 or 3 turns. And I thought, well, that's good enough. And then the same thing here. It went in about 2 turns and it stopped. And that was not modifying this at all. That was just the standard unit. It went in like 2 turns and it stopped, because this is bigger and this is smaller. So I tried it and it worked. I was happy with it. And then I was using it, and you walk away, you come back later, and I come back later and this piece had come off of this piece, and it was all around the unit. There was string everywhere. And because what happened was this piece came loose, because it was only in there 2 turns, and it came loose because moving back and forth, I guess it loosened that up and it fell out, and all the string fell out, and it was just a big spaghetti mess. It looked worse than an explosion in a spaghetti factory. So I said, well, I got to fix that, So I thought, well, the only way to fix it is I'm gonna have to tap this. And I didn't want to tap it because I really didn't know what this looked like. I went on YouTube, and they talked about these things and this and that, and I said, well, I'm gonna have to take it apart, because I don't want to make it worse. But I checked the price on these, and the whole unit, it was like $50. So I said, well, if I take it apart and I screw it up, worst thing that can happen is I spend $50 to buy another one. No big deal. So I took it apart, and everything was going good until I got to this one screw right there. Now they put these other two screws came out, but this one was like stripped. The head of it was stripped. And what they did, now I don't know why they did this. They didn't have to do this. But they use these, they're like little panhead Allen head screws. This is the screw. You see the head on that? Now this is the head off of a regular metric Allen head. You see how much smaller that is? So when you go to put your Allen wrench in there, if it's just stripped just a little bit or they over tighten it. Now there was no Loctite on here, so I guess they just over tightened it. And then when I went to get it out, it wouldn't come out. So I had to drill it out. And of course you got to be careful, because you don't want to drill into that plastic, because if you drill into that plastic, there's no flat shoulder for the screw to fit onto. It's just a big hole through there, and it defeats the purpose of putting the screw in there. But I got lucky. I drilled the centerpiece out, and then I drilled the head. The head came off, and I stopped as soon as that head twisted off. You can see it's still on the end of the drill. So I was able to save it, and then I just got some regular, well, I think they're 3x5 metric screws, and the head is a lot bigger, a lot stronger. Not that I really need the strength, but you know, when you go to put them in there, and if you ever have to take them back out, you don't have to worry about stripping that out. So I took it apart. I finally got it apart, and I need to tap this deeper to make it bigger, because the NPT, you know, the further you go, the wider it gets. And originally that only went in like 2 turns, and there really isn't a lot of depth on there. So we had this tap at work, and we had the end of it cut off, so you could go in a lot deeper, make the thread wider. So that's what I did. I went in there, I just put that in a little V block, and I just went in there with the tap, and I just made it deeper. I mean, I was real careful with it. I grabbed it here. You don't grab it, I mean, you're tempted to grab it here because it's square, but you can't do that because there's a little threaded thing in here, and this one's got these 2 little bolts in here, but normally there's a little threaded thing in there, and the wall is really, really thin. So I grabbed it here. I thought about taking this off, but there was no need to it, so I just grabbed it here. And I mean, this is a high-speed steel tap. You could get a cheap carbon steel tap, and it'll do the same thing. You're only going to use it maybe once or twice, you know, one for the feeder unit, one for the receiver unit. So now this thing fits in there really good. So now I don't have to worry about this coming loose. So I did the same thing to the block. I went in there with a standard NPT to about here, the depth. Almost to that point. And this went in, I don't remember, went in like 3 turns or something. So I went in there with this shortened NPT, and I was able to get it further, so this one goes in there good. This one almost buries itself. But that goes in there good, and I don't have to worry about this coming off. You don't have to put any sealant on there or anything. You just snug it up. I mean, if you want to put a little something on there, there's no fluid that flows through here. You just want that to be able to lock up tight and not vibrate loose. So that worked out good. Yeah, if it wasn't for that one screw that was bad, it would have been a whole lot easier to do this. But anyway, I wanted to take it apart because I wanted to do it right. I didn't want to do, you know, Mickey Mouse job. Of course, it was, you know, the part I didn't want to do was take all this stuff out of here. But there was a little set screw under here. It was really hard to see because this piece was kind of like had plastic on it. And then this little thing here fits into that hole. I don't know what that was. There's a little screw that goes in here. But I really didn't want to take this apart, but I had to, so I was real careful with it. So I got to put it all back together. But the point is that I made these two blocks. I got the other half over by the machine, and I'm real happy with the way this worked out. So that's going to go in there tight. It's going to fit on top of this unit tight. I mean, it doesn't matter if this is spaced up a little bit. In fact, it's better because then it doesn't get as hot. But yeah, that worked out real good the first time. It's going to work out even better now because now it's not going to come apart. And as far as that the leveling, I showed you that plate I made that moves up and down on this unit. That'll make this move up or down so I could adjust that thickness of that plastic when it comes out. Now that was a great idea, but I'm trying to adjust it while the unit is moving, and it's like really hard because the unit is, you know, is moving all around and you're trying to adjust it. So I did a little research on that, and I found out that there's a thing in the control that does that for you, and I don't have it on me right now, but it's some kind of little Z control, and when the unit is moving, you can go into the control and you can rotate the knob, and it makes the unit move up or down depending on how much you move the knob and what you have it set for. There's some kind of Z-axis well, it moves the unit up and down while it's printing, is what I'm trying to say. And it works out real good. So I'll have to get that or demonstrate that later on. But I just wanted to show you this now because you know, when you come up with a good idea, at least I think it's a good idea, you know, I try to pass it on to maybe somebody else will think it's a good idea, and because they're having problems, and maybe this will solve their problems like it solved my problems. So anyway, that's kind of what I'm trying to say. And these are little connectors. I had to tip the unit on its side to get these little connectors out. You know, it's like these connectors they use in the car. I mean, you gotta have all these special tools to undo them and this and that. And it's you know, sometimes it's ridiculous. You know, all you want to do is just take the plug out. But I think the you know, these engineers, they try to make it as hard as they can for you. I don't know. But anyway, we got it apart. We're going to put it back together. Get this thing going again. But I wouldn't have taken it apart if I didn't think I was doing something positive with it. I mean, I don't take it apart just to take it apart. I got too much to do to just sit here and play with it. It's got to be something worthwhile, because I got a lot going on. And so anyway, that's going to work out good. All right.